First, create two methods, one for when we start our wall run and one for when we stop. Call the start wall run method when there is a wall on the left or the right, and call the stop wall run method when there is no wall on the left or the right, and when we can't wall run. Then declare a field for our rigid body and in start, get the component. In our start wall run method, we first need to disable gravity on our rigid body. Then we need to add our downward force, so let's declare a field for the force amount. I'll call it wallrun gravity. And we can use rb.addForce. Pass in vector3.down for the direction, and don't forget to multiply it with the force. I'm going to use forceMode.force for the force mode. Next, we will detect if the player uses the space key to jump, and apply a force relative to the side the wall is on. So we need to create two raycast hits, one for the left and one for the right. In the check wall method, out the hit info to the respective raycast hit. Now add an if statement to check if the player presses the spacebar, then check if the wall is on the left, in which case we will first calculate the direction the player should jump off the wall. We can create a new vector3 which will be transform.up plus the wall's normal. This will give a diagonal vector. You can normalize it if you want. Then before we apply the force, you want to reset the player's velocity on the y-axis. Now we can apply the force. Create a new float for the wall jump force and multiply it with the wall run jump direction for the force. Then pass in forceMode.force for the force mode. And we can do the same thing if the wall is on the right, but instead we want to use the right wall's normal. I would also recommend multiplying the force by 100. In the stop wall run method, you can just enable gravity on the rigid body. Now let's add some cool effects like camera tilt and field of view change. First we need some variables, a float for the normal FOV, a float for the wall run FOV, a float for the time it takes to move between the normal and wall run FOV, a float for the camera tilt and camera tilt time, and finally a float for the current tilt, which will be public. And we also need a reference to our camera. Add the serialized field attribute so we can see it in the inspector. When we start our wall run, we want to lerp our camera's field of view to our wall run FOV. Do the same thing when we stop our wall run, but instead lerp it to the normal FOV. Let's test it out. Reference the camera by dragging it, set your normal FOV, wall run FOV, and the time. As you can see, our field of view is increasing when we wall run, giving a cool effect. Now for the camera tilt. We want to check if the wall is on the left, in which case we want to lerp our tilt to negative camera tilt and pass in camera tilt time multiplied by time.delta time for the time. We're using negative camera tilt because we want our camera to rotate that way since the wall is on the left. Then add an else if statement to check if the wall is on the right, in which case we want to do the same thing but instead use positive camera tilt. Now in the stop wall run method, add an else statement in which you lerp the tilt to 0. In the player look script, get a reference to our wall run script, then where you rotate the camera, pass in the tilt property instead of 0 for the rotation. Don't forget to assign the wall run script to the player look script in the inspector, then you can test it out. Congratulations, you've done it. Anyways, thanks for watching.